In this video, I'm going to show you how to use a little bit of algebra to find some unknown lengths when you are dealing with similar triangles. So we are told right from the beginning that triangle PQR is similar to triangle NMR. In most cases, my big secret, my shortcut for you, is to draw the triangles separately. So for example, in this case, we might take the smaller triangle on the inside. All right, I'm just going to try to trace it. Okay, so here's the smaller triangle from the inside. So I'm going to take this and put it over here. And now I'm going to take the larger triangle that's on the outside, and I'm going to trace that. All right, and I'm just going to slide that over here. So let's see if we can label the triangles and see what we've got. So for the smaller triangle, this was M and P and R. No, yes, M. Okay, I see where I messed up. This for the smaller triangle, this is MNR. So this is MNR. For the larger triangle, this is QPR. Now let's find some lengths. For the smaller triangle, I have X right here, and this side is 60. Okay, that's all I know. Now for the larger triangle, QR, we're told by this arrow that QR is 63. Now what about PR? Well, PR is the 10 and the 60, so that's a total of 70. So for the rest of the problem, I'm really going to look at the two triangles that I have drawn separately. So I'm going to label this triangle as new and this triangle as old. It doesn't really matter which one is which. This is just because we've learned that we can make a new proportion, a new equation in the form new over old equals new over old. If there's one X somewhere, I usually just pick that triangle and I call it new. All right, so as I match up my corresponding sides, I see that X and 63 are corresponding sides, and I see that 60 and 70 are corresponding sides. So when I do new over old equals new over old, that's going to be X over 60, that's going to be X over 63 is equal to 60 over 70. So then it's just a matter of cross multiplying. So I can make a new equation by multiplying this diagonal. So that would be 70x. And I'm going to set that equal to the multiplication of the other diagonal. All right, so I'm just grabbing my calculator. And I'm going to do 63 times 60. So 63 times 60 is 3,780. So I'm left to just divide both sides by 70. So in my calculator, I'm hitting divided by 70, and I'm getting X is 54. Okay, let's move on to problem number 2. again, my number one strategy is going to be to draw these triangles separately. There's one exception that we're going to run into in a minute, but most of the time when you see one triangle sitting inside of another triangle, split those apart. Okay, so there's my small triangle. And now here comes the big triangle. All right, there's my small triangle, and there is my big triangle. Okay, let me take this down a little bit so we can see what's going on. Now, the small triangle is triangle QNM. And then the large triangle is triangle QSR. Look at this small triangle. Side QN is 27, and side QM is 39. And side NM is 30. Okay, now look at the big triangle. Side QS is 72. Got that big old 72 right there. And then I have X down here at the bottom. So let's match up our corresponding sides. The X and the 30 are in the same position, so they are corresponding. And the 27 and the 72 are in the same position, so they are corresponding. The 39 is in the same position as this empty space. But since the 39 doesn't match anything, I'm really not going to use that. So I might as well not even highlight it. I might as well just stick to the yellows and the blues. Now let's pick one of these triangles to be new and one to be old. I usually pick the triangle that has X on it, and I call that new. It doesn't really matter though. What matters is when I set up my new equation, when I set up an equation, I'm going to do it in the form new over old equals new over old. So if I do the yellows, new over old is X over 30. For the blues, new over old is 72 over 27. And then we just cross multiply. So when I write my next equation, I'm going to multiply the down diagonal, and of course that will just be 27x, and then I will multiply the up diagonal, whatever 30 times 72 is, and I just put that in the calculator. 30 times 72, that's 2,160. So then all we have to do is divide both sides by 27. So we'll just go divided by 27. And we get 80. So therefore X is equal to 80. Now problem number 3 is the one time when I would not draw the triangles separately. You could, it would be a little bit complicated because this long side over here, you'd have to understand that this is X plus 52. And that expression is going to make your calculations a little bit more complicated than they normally would be. Honestly, that will make it more complicated than it needs to be. Because in this case, I can use something called the side-splitter. theorem. Okay, you can use this when you're only looking at the sides and you're not dealing with the bottoms of these triangles. Okay, this is for sides only. Okay, no bottoms. All right, so whenever you have a picture where all your numbers and x's are on the sides, like they are here, and none of the bases of the triangles, that's not what you're looking for. That's not what you're dealing with. That's when it's good to do the side-splitter theorem. So instead of looking at this as two separate triangles, we can just split this one triangle into two zones. So we've got this yellow zone, and then down here we've got the blue zone. All right, so when we make our proportion, we can just go, instead of doing like new over old like we usually do, we'll just go yellow over blue equals yellow over blue. So on this side, if I do yellow over blue, that's going to be x over 52. On this side, I can just make a fraction out of these, and that'll be 84 over 48. So this is much simpler than drawing the triangles separately. But it only works when you're dealing only with the sides. That's why it's called the side-splitter theorem, because we're simply splitting the sides. But the rest you would solve the way you normally would. We will multiply the down diagonal, which will be 48x, and then we will multiply the up diagonal. So 52 times 84. 4,368. And then, of course, we will divide both sides by 48. So we'll just go divided by 48. And that's 91. Okay, that's a special case though. For most of these other problems, I'm going to stick to my original strategy of drawing the triangles separately. So on this problem, I see that I'm back to dealing with the bottoms of these triangles. So I'm going to go back to drawing the triangles separately. Okay, so let's start with the small triangle. And then now let's do the big triangle. All right, so for the small triangle, this is G and H and T. For the large triangle, I've got U and V and T. All right, on the small triangle, I have the X and the 26. So for the small triangle, I see the X and the 26. On the large triangle, I see the 70 up here. So there's my 70. Now, what about this UT? Be careful because UT is the 16 and the 26. So that's going to be 42 because I'm doing 16 plus 26. All right. Now that we have it drawn separately, it's pretty easy to see that these are corresponding sides and these are corresponding sides. So just pick one triangle and call it new and call the other one old. Because then we can just do new over old equals new over old. Starting with the yellows, that's going to give me x over 70. And then the blues, new over old, will be 26 over 42. Then it's time to cross multiply. So we will multiply the down diagonal, and that will be 42x. And then we will multiply the up diagonal, 70 times 26. 1,820. The last step is to simply divide both sides by 42. I'm going to go back and double check this in a second, but for now, I'm getting 43.3, so I guess I'm going to round that. Did they tell us how many decimals to round to? They don't say anything about decimals. So how would I write that as a fraction? Okay, well that's just 130 over 3. So if I was not allowed to use decimals, I would put something like this. All right, let's go on and take a look at problem number 5. Okay, well this time they drew the triangle separately for us, so that kind of saves us a step. It makes it even more important that we match up the corresponding sides though, because the triangles are not necessarily rotated the same way. So let's be very careful. For example, I have side NL. Notice that NL is right here in the similarity statement. That's going to correspond with QR. So I see here's QR right here. So that means the 45 and the 81 are corresponding sides. All right, now on the other hand, I've got the 3x plus 3 happening. That's ML. Here's ML at the end. That's going to correspond with RS. Here's RS up here, so those two are corresponding sides. Now pick one triangle to be new and one to be old. It does not matter which one you pick. This is just so you can make your equation in the form new over old equals new over old. All right, so looking at the blues, new over old would be 3x plus 3 over 54. Now looking at the yellows, new over old is 45 over 81. Okay, now it's time to cross multiply. So if we look at the down diagonal here, I have to do 81 times 3x plus 3. Be careful because I actually have to do the distributive property. So I'm really doing 81 times 3x plus 3 like this. All right, but I'm going to just go straight to that. So the question is, what is 81 times 3? That's 243. So that's going to give me 243x plus 243. And then I need to multiply the up diagonal. All right, 54 times 45. 2,430. All right, to solve this, I will subtract 243 from both sides. So that's 2,187. And finally, I will divide both sides by 243. And I'm getting x is equal to 9. Okay, as I look at problem number 6, it looks like we're back to this overlapping triangle business. So I think I'm going to use my old strategy of drawing the triangles separately. All right, that's probably the best thing to do when you see overlapping triangles, unless you're dealing with only the sides. Okay, so this is my big triangle. And now here comes my small triangle. All right, it's all about drawing the triangle separately. 9 times out of 10, you want the triangles to be separate. Okay, look at the small triangle. I see I've got the 65 and the 55. So I've got 65 and this 55. Oh, I should label these. This is M and C. So M, N, C. All right, now the large triangle, so this is D, E, C. But what's going on here? So side DC is this long blue arrow. That is 26x. Now, what about side CE? Side CE is 55 and 33. So that's going to be 88. Okay, now let's match up the corresponding sides. So obviously these are in the same position, and these are in the same position. Pick one triangle and call it new, and call the other one old. It really doesn't matter which. I usually call the one with the X on it, I usually call that one new. But the only point is so I can make an equation in the form new over old is equal to new over old. It just helps me make sure the equation is in the right order. So if I do the yellows, new over old is 26x over 65. And now if I do the blues, new over old is 88 over 55. So time to cross multiply. I've got my down diagonal. Okay, so what's 26 times 55? So that's 1,430. Now I need to do the up diagonal. So 65 times 88. 5,720. So of course, for the last step, we will divide both sides by 1,430. Divided by 1,430. 4. X is equal to 4. Okay. Again, for this problem, we have the benefit that the triangles are already separate for us. But the downside is we need to be a little bit more careful. Wait a minute. How long has this been going on? Okay, I just realized that back on problem number 5 and 6, we were supposed to find an additional piece of information. We're supposed to find ML and DC and DM. So I need to go back and do that real quick. So we found X, but we're supposed to find ML right now. Well, ML is this expression right here. It's 3x plus 3. So that's going to be 3 times 9 plus 3. All right, well, 3 times 9 is 27, and 27 plus 3 is 30. So ML is going to be 30. Okay, let's see what's going on this problem. We're supposed to find DC and DM. Well, DC is just 26x. So that's just going to be 26 times 4. So that's 104. And then what about DM? Oh, okay. DM is not one of the sides of the triangle. So notice that DM is this little piece right here. But we just found DC. DC was 104. So that's all of this. So we just found that this whole length, DC, was 104. If the whole thing is 104, and then this piece right here is 65, how can I find the other piece? Well, it should be the whole thing minus 65. So if I do 104 minus 65, that leaves 39. So that means this piece over here must be 39. All right, again, they have to add up to be 104. So I think you'll find that 39 plus 65 is 104. So DM has to be 39. All right, I'll just have to be careful and watch out for that on these last two problems. Okay, we got those extra pieces that we were going to have to find. Anyway, back to number 7. The corresponding sides. So this side right here, that's LN. LN is right here. That corresponds with GL, and GL is this guy right here. So don't assume they're across from each other. You would be wrong in this case. Okay, so those are the corresponding sides. Now let's look at well, let me change to blue. Look at the 27. That's LM. LM, that's the beginning and the end here. So that's going to correspond with LF. LF, of course, is right here. So those are corresponding sides. Okay, now pick which one is going to be new and which triangle will be considered old. It does not matter, but when you write your equation, put it in the form new over old is equal to new over old. I'm going to start with the yellows. So new over old would be 2x minus 4 over 24. Now I'll do the blues. New over old. That's 27 over 18. Now remember, when I multiply the down diagonal right here, I have to do 18 times 2x minus 4. Please remember that I'm doing the distributive property though. I'm doing 18 times 2x minus 4. So I'm actually doing 18 times 2 and 18 times 4. All right, I'm not going to show this. I'm just going to do it. So of course, 18 times 2 is 36. So I'm going to have 36x minus. Now 18 times 4 is 72. All right, so again, that was the distributive property. I'm multiplying 18 times both of these. Now, for the other side of the equation, as always, we will multiply the up diagonal. So 24 times 27. $648. Okay, let us add 72 to both sides. So that's going to give us 36x equals 720. The last step is to divide both sides by 36. And you get 20. But this time I won't make the mistake that I made a minute ago. There's another step. We need to find ln. ln is the expression 2x minus 4. This is ln. So if I do 2x minus 4, that's 2 times 20 minus 4. 2 times 20 is 40, and 40 minus 4 is 36. All right, last problem, guys. Be careful about your corresponding sides. Notice the pictures are identical. I've got the 24 and the 18 and the 2x minus 4 and the 27. The pictures are identical, but yet it's a whole new problem because the similarity statement has now changed. That's the only way you know. You have to look at the similarity statement. So here's ln. Okay, now in this similarity statement, ln is at the beginning and the end. So that's going to correspond with LF this time. Okay, so LF is right here. So last time it was corresponding with the 24. This time it's corresponding with the 18. You have to use your similarity statement. That's the only way to know what goes with what. Okay, anyway, look at the 27. That's LM. Here's LM. That corresponds with GL. And GL is right here. So these are corresponding. Okay, so I'm going to call this new, and I'm going to call this one old, and I'm still doing new over old equals new over old. Starting with the yellows, that will give me 2x minus 4 over 18 is equal to 27 over 24. All right, and now it is time to cross multiply. Don't forget, we are doing the distributive property. We're taking the 24 and we're multiplying it by both of these parts. All right, so 24 times 2 is 48. So I'm going to get 48x. Now 24 times 4 is 96. And now we do the up diagonal. 18 times 27. 486. Time to add 96 to both sides. That's 582. And finally, we will divide both sides by 48. Divided by 48. Oh, another decimal, okay, 12.125. Okay. Now, if I want to find ln, ln is 2x minus 4. So that's going to be 2 times 12.125 minus 4. So that's 20.25.